Hello and welcome. My name is Ben Gartland, and in this video I will show you how to use the Digi TransPort router's Analyser Trace. The Analyser Trace is a really cool feature of our routers that allows you as a network administrator or support technician to troubleshoot traffic that is either going to or being routed through the router. In this first part, I'll run through the options shown in the configuration page, but we'll concentrate on the options needed to trace Ethernet and IP packets, including how to use the filters. So let's get started. I'm using a WR41V2, so it has Ethernet, cellular and Wi-Fi connectivity. Once you've logged into the router, navigate to Management, Analyzer, expand the Settings section, and here you'll see the basic Analyzer configuration page. Depending on the router model, you may see more options than shown here, you may see less, but the options we will be using in this demo are available on all platforms. The maximum packet capture size defaults to 128 bytes. Depending if you need to see the packet payload or not, 128 bytes may be sufficient. Generally, whenever I'm doing traces, I always set this value to 1500 bytes to ensure I capture the full packet payload. The log size defaults to 45 kilobytes. I normally set this to the maximum of 180. Now the log is a compressed file, so you will be able to store more than 180k of data. The protocol layers 1, 2, 3 and XOT are used for everything except for Ethernet and IP. So if you're doing online authorization or maybe ISDN communications, then the protocol layers up here will have an effect. Otherwise, for basic tracing like we're going to be doing today, these aren't required. IC tracing is for use with IPsec VPN negotiations. We'll cover this in another video. The QMI trace is for the management and status data between the router and the cellular module. Ignore LAP-B links, we won't be using these either. The serial interfaces can be used to trace data in or out of the ASY interface on the back of the router, or serial ports used to connect the cellular module to the router or a PSTN modem, for example. If we scroll down a bit, we'll see the Wi-Fi analyzer configuration. So this can either be enabled or disabled with the checkbox. There are two options, one for the management packets and one for the data packets. For the management packets, in the drop-down, you can either trace nothing, all packets, or everything except for beacons. We get similar options in the data packet analysis, none, everything, or everything except for null data. Now we get into the sections that will mostly be used. Ethernet interfaces trace at layer 2, so we're tracing Ethernet frames. Selecting these checkboxes will show Ethernet frames for the specified sources. Sometimes we'll need to see layer 2 frames, but usually these can be left disabled. Tracing at layer 2 can be useful if you need to see the VLAN tags. You may also need to trace ARP traffic. That can be seen if you enable the layer 2 interface. Moving on to PPP interfaces, these are normally used to trace PPP negotiations. The most common uses are when links are not coming up as expected. So for example, when connecting to an ISP, this could be an ADSL connection or PPPoE or PPP over a serial connection. It can be used to trace the traffic between the router and the cellular module, but often that data isn't all that useful as we don't really see what's happening between the cellular module and the mobile network. IP sources is for tracing at layer 3, so we're talking TCP, UDP, ICMP. If data isn't routing as expected or packets are going missing, this is the place to start. IP tracing can be configured on Ethernet interfaces, PPP interfaces, and OpenVPN, here shown as OVPN. Tracing can also be enabled on GRE tunnels, but this is done within the tunnel configuration page. We kept these separate because some of the routers can have hundreds of GRE tunnels, and having that amount of tunnels on this page would make things slightly cluttered. The next two options, trace discarded packets and trace loopback packets. The most useful out of the two is going to be trace discarded packets. So if you see a packet coming into the router but not leaving the router, and you expect it to. Then enable trace discarded packets, and you'll probably see that it's being dropped for some reason. Then right at the bottom of the page we have the filters. Here we can filter in or out specific traffic. So we can trace at layer 2 and apply filters to MAC addresses. We can filter in MAC addresses or filter out MAC addresses. To filter in, you use the tilde symbol followed by the MAC address. To filter out, you simply remove the tilde and put in the MAC address that you want to filter out. IP packet filters are the filters we can apply at layer 3, so TCP and UDP port numbers. Again, you can filter in tracing of SSH and Telnet, like so. Or if you want to filter out web traffic, then you can just type in port 80. IP protocols can also be filtered on, so again, same principles apply. Tilde to filter in, so protocol number 1 is ICMP. If you want to filter out ICMP so it doesn't appear in the trace, just put the number in without the tilde. Again, separating with a comma if you need to. IP addresses, you can specify either a single host, as shown here, 192.168.1.1, and you can also specify a subnet, but it has to be in CIDR notation. So here we're filtering in the single host 192.168.1.1 and the subnet 172.16.0 with a 24-bit mask. That's not to say that the traffic is coming from a network with a 24-bit mask. That's just to say that anything that starts 172.16.0 will appear in the trace. Likewise, the same occurs for the discarded IP packet filters. If you enable trace discarded packets up here, then you can filter in or out traffic depending on the requirements. So that's a quick rundown of the Analyser Trace functions. I think we'll stop there and move on to a new video for tracing some live IP traffic. I hope you found this useful, and thank you for watching.